Hi everyone, welcome. Thanks for coming. I'm glad to see that there's some ISO 27001 enthusiasts in the room. My name's Mike and this is Øyvind. We're going to get into our introductions in a minute, but we're going to talk about a project we've worked on together over the last little while about, essentially Stacc's journey to ISO 27001, which is kind of unusual, but then again, not that different from a lot of journeys in this space. It's usually a lot messier and a lot of things to figure out on the way. And we're going to talk a bit about how DevOps played a role in this. Good. So just as, maybe Øyvind, you can start introducing yourself.
Yeah, so Øyvind, I'm an architect, developer, and a bit of everything else man in Stacc. I was the co-founder of one of the main products that Stacc delivers. Yeah, Mike?
Yeah, and my name's Mike. I'm the CEO, co-founder of a company called Causley. We're not going to talk about Causley today, but it's essentially like a flight data recorder, a black box recorder for what's going on in your DevOps and your infrastructure. Great. Well, without further ado, let's get stuck in.
Right. So, as Mike mentioned, we at Stacc planned on introducing ISO certification, and I'm going to go a bit into more of the details around that and why. But first, I wanted to introduce Stacc. Stacc is a software company that delivers software for banks and other financial actors. And it's a relatively young company compared to a lot of the competitors that we have. It was established in 2016. It has roots that go further back, but that was when it was officially established. Right now we're at around 190 employees, and we have a lot of different customers, both like large Nordic brands, as you can see, and also like smaller challenger banks or fintechs. And it's been growing pretty extensively for the last couple of years. When I started in 2016, we were 10 people, and now we're around 190 and growing. And we're also grown from our Bergen headquarters into Oslo. We're actually opening a new Oslo office tomorrow. We recently acquired a company in Sweden, in Skövde, which is in the middle of the country there. We have a Stockholm office that has currently 1 employee, but it's growing, and we also have a development team in Belgrade. Most of the developers today are in Bergen, though. And the way that Stacc has grown has been a combination of organic growth. So when I started, I founded a team of developers in Bergen, and we grew kind of organically. But we also bought several companies and integrated them into Stacc, and that's also going to be important for a topic. Because when you have an organization that is kind of comprised of different entities, you typically get a lot of spread, both in like terms of organization. You have kind of different subcultures. Some of these, again, departments today used to be independent companies. You also have a lot of spread in terms of programming languages and environments, and also tooling. And that makes it relatively complicated to do stuff like across the board. So our culture, again, it's a bit like spread, but we tend to be relatively agile in what we do, working closely with customers, collaborating, and delivering value as quickly as possible. The teams that in Stacc are autonomous. They're relatively empowered. There's almost no hierarchies, other than like the required ones like CEOs and stuff. And we also have a relatively strong DevOps culture to automate everything that has to do with like nitty-gritty deployments and all that kind of stuff. Yeah. So ISO certification. So I'm not a compliance expert. I think Mike is has to play more of that role. But I know a little bit about this after this last year. So we in Stacc decided to go for 2 certifications, ISO 9001 and ISO 27001, for quality management and information security. And again, like in this talk, information security and aspects of that is going to be the most important. So yeah, so just like the high level on ISO 27001, it's basically a standard for information security, like a framework for managing like sensitive information. And the main reason that people would want to certify is that that basically tells everyone else that you are following a certain standard when it comes to taking care of customer data. So you can basically say that, trust me, I know what I'm doing because I have this certification. That's basically the selling point there. Yeah, so it contains a lot of different stuff like risk assessment and incident management processes, security controls. We're going to mostly focus on the stuff that the developers have to deal with on a day-to-day basis. So what you call the change management process is going to be the main focus of what we're talking about here. Yeah, so why does Stacc want to be ISO certified? Well, as mentioned, we operate in a regulated field, which means that there are certain expectations that come with that, and you also have you are protecting data that is sensitive, and sometimes you could potentially also have the ability to trigger like financial transactions, which means that there's a lot of it's a space that you need to be especially careful when it comes to like delivering software. And as mentioned, we've grown from a small company with small customers to a larger company with larger customers. And the larger the customers, the higher the demands are. And the organization is growing, right? So what used to be easy with 5 or 10 people is now starting to become pretty complicated when you have 190 people that have to do the same thing. So it's basically it's an expectation at a certain point that you need to have some sort of stamp of approval that you're doing stuff like this correctly. Yeah. So, as a developer, I had some concerns because I've been around the block in different organizations of varying size. I've seen that when you introduce these kinds of frameworks or standards, you tend to kind of use like the default setup. And the default setup is not really about speed and autonomy. It's basically it's like more about paperwork and bureaucracies and hierarchies. And I was really concerned that when we were going to introduce this, someone was just going to take something off the shelf and say, here's our process. We have CAB meetings, we have like checklists, and yeah, that sounded nightmarish to me, to be honest. So yeah, so I wanted to keep the autonomy of the teams. I wanted to keep the speed and avoid too much bureaucracy. Because what we really didn't want to do was to go back to the bad old days before DevOps, where you had like these extremely long lead times and delays built into your processes. So basically, how can we keep doing DevOps in autonomous teams while still being compliant? That's a big question. And luckily, I knew a couple of guys in Oslo who just started a startup that were solving this specific problem. So I'm going to hand it over to you, Mike.
Great, thanks, Øyvind. That's great. So yeah, so I mean, this is the kind of the challenge that I'm kind of very curious about. Because again, like Øyvind, I'm a technologist, but I've been before, in my current role, I was a DevOps consultant. So I tended to go around to lots of different companies and automotive, banking, healthcare, finance. And you know, the challenge for them was they wanted to do DevOps, but they had like, you know, rules and stuff about how they wanted to do this. So it was like finding out how to marry these two concerns has been kind of a big part of my career for the last 10 years. So, I mean, how can we merge these two worlds? How can we get the agility, the speed of DevOps and still like build compliance into the way we do software development? So what's interesting about software, and Stacc is a great example of this, is that most organizations, especially those that have some kind of regulatory or standards to meet, they have a history. And the history goes over many, many years, sometimes decades. And if you go back to when I started software development, the typical way of developing software systems was on a big server in the basement or in a server farm somewhere. It was a very monolithic system. It was very slow changing. It was things like WebSphere or any kind of web application server, IIS, even mainframes in some cases. And then through the years, we've kind of gotten to maybe more lightweight Intel-based servers, more distributed systems. Eventually, microservices came into play, and now we've got functions as a service, Lambdas, and edge computing. And what's happened through this whole process is that the reason why we've gone down this path is we want more agility, we want decoupled systems, faster development rates. So this journey has been good, but what we end up with is typically an organization will have software across this whole landscape that has to follow a process. So maybe in a greenfield startup, you can have everything on, say, Kubernetes or whatever, have a very uniform platform, have one system for defining your process, keeping your requirements. But that is actually quite rare in most software organizations. So some of the challenges you have when it comes to, especially in these regulated or compliance areas, is that there's tool sprawl. There's lots and lots of different tools, and as the systems grow and as the teams grow, you quite often don't have a good record of how systems actually change. Quite often the dev tools and the operations tools are very siloed. So you might have a really great monitoring stack, but it's not really connected to what's going on in the world of development, for example. And very often, for the developers, they don't have any visibility into what happens after a Git push. So what softwares and what environments and how the environments are changing doesn't really relate to the code that they have. So these all have real-world impacts, right? There's the missing visibility across teams. So these systems all depend on each other, but if you depend on another system and it's changing, it can be very difficult to figure out, who do I talk to? What's changed? Has anything happened this morning? Is my system failing because of another downstream system has changed? These things are hard. A lot of guesswork and frustration around incident response because of that. And then this third point is the point that we're kind of really concerned with here is uncertainty around security and audit compliance. Do we actually, if the auditors came in tomorrow, would we be able to stand up to an audit? And finally, developers just are finding it more and more difficult to figure out what's going on as these systems become more distributed, as they change more often. Does anyone know this company? So this is Knight Capital. They were, I say were because the story's quite interesting. They were a high-frequency trading firm. So they were basically making money by buying and selling shares faster than anyone else. That was their business. And they had a really bad day in 2012 where they had some test software in their system that would buy at a high price and sell at a low price. And it would do it really, really quickly. So the reason that code existed was as a way to test the safety valves in the system. This software was never supposed to run in production. It was hidden behind a flag. What could go wrong, right? But unfortunately, this flag happened to be repurposed for another use and get switched on in production, which again, kind of unfortunate. But these are the typical errors you have in software. So they lost over $400 million in a day. and not long after that, they were acquired at a rock bottom price for their technology. So, I mean, these are, I mean, this is a kind of an extreme example, but the story behind this is really fascinating from the compliance and audit perspective, because when a company explodes like this, especially a financially regulated company, there's usually a big investigation. It's like Inspector Clouseau comes around, and it's like a murder mystery to be solved. So there's all kinds of people with suits and checkboards will go and piece apart what's gone wrong and figure out exactly who's going to get blamed, who's going to jail, who's getting fined. And it all ends up in a report, which I'll come to. But in the case of Knight Capital, it was the SEC in the US that was the regulating body, and they came in and they did an audit. And like, if you're a financially regulated company in Norway, this is actually the law that you're required to follow. It's the IKT forskrift, which is not what Stacc is actually trying to comply with, but many of Stacc's customers are. And it's funny because like there's not much in here, right? It's like you should have a system, you should have a process for how you develop your systems. And it's 14 very short paragraphs, and the auditors come in and they'll have a different opinion about what they're going to look at every single time they come. But some of the typical things they'll ask about, like, do you have a software process? What is it? Where is it written? Do you actually follow it? Like, you say you do code reviews. Show me. Like, where's the proof that you do code reviews? And they'll go step by step through your process, and ideally your process would take the risks in your world, be they security risks or whatever, you map them into controls in your process, and then those controls will have some kind of evidence that the auditors can go through and to ensure that you followed the process. So that's roughly how this process works. So going back to Knight Capital, the great thing about their murder mystery investigation is that they end up coming out with reports. And they tell you exactly what was found. And the Knight Capital one is great to read. It's only 18 pages. It's very, very simple, very high level, not a lot to go into. But it kind of just lays out in pretty plain language what they found and what they should do differently going forward. And yeah, so the clue is that there was a cease and desist order, which I don't know if you're familiar with the world of finance, but when you're not allowed to trade anymore, it's very difficult to stay in business. So let's go into some of this. Like we've mentioned software process. So when it came to Knight Capital, they did not have a written code development and deployment procedures for this particular system, which is already a massive compliance problem. Because if you don't have a process, how can you ensure that you're following a process in the way you work, and how can you be successfully audited? And yeah, I mean, this is getting into some more details, but they didn't have a protocol concerning the accessing unused code on production servers, which I think most companies would not have something written about that either, because you wouldn't expect unused code on production servers in the first place. So, okay, everybody needs a software process. If you're ISO certified, if you're a financially regulated industry, if you want to get SOC 2 compliance, whatever it is. But roughly, the way it works is that there's some rules and regulations, like the IKT forskrift or the ISO 27001 framework, that it's up to every single company to implement for themselves. So they have to figure out, based on this rules or these frameworks, exactly how to interpret that into the way they do their work. So Øyvind hinted at this. Most commonly, the way this works is that companies will buy a documentation pack. They will spend $20,000 and get a bunch of Word documents that they can put on their wiki pages. And then they copy and paste it and massage it how they want, but you're expected to have a body of documentation about how you do the work. Now, the idea is that that documentation represents your actual processes in your company, and you're kind of required to follow those processes and produce the documentation as proof, because when the auditors finally do come and check it out, they want to see that you've actually done what you say you do. So another important thing is that mostly these frameworks and regulations and so on, they don't say that you should have meetings, that you should write documents or have JIRA tickets or any of this stuff. It's just commonly how it's been done, so this is how people have been doing it. And getting back to the world of software development, that has a real impact often in your software development culture, right? Because you end up with a change advisory board meeting to do a change. So imagine you had to go and have a meeting and produce documentation every time you wanted to do a deployment. That's actually the reality for a lot of financial companies. That's how they do it. And you can imagine what that means. It means that they do quarterly releases instead of daily releases. It means they batch up a lot of change. It means they have a lot of risk. It means developers don't really feel like they're getting anything done. But that's just one example. You have security checklists quite often, like special JIRA tickets where you need to tick off all the different things you're supposed to have done. And it goes on and on and on. And yeah, these things have a real impact on the developer. It means that you feel unempowered as a software developer. It means that you don't really feel like you're managing risk, you're just doing check marks. It means that there's a lot of delays in your work. You implement your feature, but maybe it gets shipped weeks later. And if there's a bug, it can take a while to figure out what exactly is going wrong. And all of these things are, right, go on fin.no now and have a look at the job vacancies for technologists in the financial sector. There's loads of them. DNB's hiring, all the banks are hiring. Nowhere do they mention this. But, I mean, it's the reality, right? And the other part of it is that all of this documentation, all of this process, all of this is just a theater in the end, because smart developers find a way. You know, I mean, okay, guess what? If I have to do a change request every time I'm going to deploy, well, I'm just not going to deploy very often, or I'm going to make it my manager's job. So like a lot of this busy work ends up going into like Scrum Masters roles or team leads, and it just kind of, you know, disappears, but it doesn't disappear. It just, the developers kind of try and find another like happy little island where they can pretend it doesn't exist, which again kind of goes against DevOps, goes against Agile. It's generally disempowering for everybody. So what we're quite lucky about, happy about, or maybe it's just the natural conclusion, is that, you know, there's enough problems backing up here that compliance and security can become the bottleneck in organizations. And it's starting to become a bit more accepted that there's new ways to do this. We can solve a lot of these risks, we can solve a lot of these controls, we can solve a lot of the audit and documentation requirements automatically in our DevOps. So last year, a book came out from IT Revolution. This is the publishers behind the DevOps Handbook and the Phoenix Project and these kind of books. It's all about, it's exactly like the Phoenix Project in the sense that it's a novel about, you know, it's kind of a story about how a team or a bank gets an MRIA, which is like kind of like a matter requiring immediate attention from the regulator, and they talk about how they solve this around DevOps. And what's quite interesting as well is that in the story, this is a company that's been through a DevOps transformation, and then they've found that they've kind of ignored the audit and compliance parts of the story, ignored the security. So it's about how to bring back those different needs into the organization. And in the book, they talk a lot about things like immutable attestations, like providing your evidence in a way that doesn't change, so the auditors are happy, having compliance and controls and code and so on. Next year, there's a book coming out as well from the auditor side, which I'm very excited to read, but we'll have to wait a few more months for that. So getting back to the story, like, how do we solve for some of these ISO 27001 requirements without a lot of pain for the developers. So the trick is, like, can we do it with, like, kind of maintaining a DevOps culture in our company, and can we ensure continuous compliance rather than like checkpoint or gated compliance? And the way to do it is to build it into your DevOps. So there's kind of many different concerns you need to focus on. At the basis, you need secure builds. Like the very bottom of the triangle, if you like, in terms of the hierarchy of needs, is you need to know your software, how it's built, what its ingredients are, and so on. And then on top of that, you layer on like a provable process that you've done your controls, be that code review, deployment controls, security scans, and so on. And then finally, the runtime has to be secure, and this is where you get into admission controllers and making sure that you've got complete logs of everything that's run in production. And then beyond all that, for meeting the regulator, you need a log of all of that stuff. So I'm just going to dig into a few of these different concerns. I'm not going to go to every single detail, but like the absolute very basic thing in terms of a secure supply chain, a secure SDLC, security at all in your DevOps is to be able to identify your software. You'd be surprised how difficult this is for a lot of companies, or how few companies actually have a good record of what software has been built and where it came from. So artifact binary provenance is a fancy word, but it's a really simple idea. So the idea is, in your build process, on your CI system or whatever, when you produce an artifact that's going to be deployed, be it a Docker image, a jar file, an exe, whatever it is, you run it through a hash algorithm like SHA-256, take a digest of the contents of this, and you store it somewhere in a system of record. So that means you've now got a record of everything that you've built. And ideally, you would store some other information, like the build URL, the git commit that it was built from, the software bill of materials, and whatever you find interesting. But that's all it means. And you can do this pretty simply, just like with, maybe this is a little bit too small. Yeah, but you can just say you take a digest of the artifact in your build process, record it somewhere, put it in an artifact, store it in a Git log, whatever. But this is the basics. And then there's a lot of open source projects coming out now, and standards like Salsa and Sigstore, Cosine, and so on, that help in this. So the next level is like, okay, now you know where your software came from. How can you start to mitigate against supply chain attacks? So the very first thing is, like, if we take the SolarWinds example, where that was essentially a build tool attack. So MS Build was compromised and injected nefarious code in. So the way to kind of mitigate these kind of risks is to use a managed build service like GitHub, whatever you prefer, to make sure that the build servers themselves can't be compromised, and then make sure that you build in an immutable environment like a Docker container, so that you know exactly the state. You can scan the state of the build infrastructure, and of course, these themselves are potentially artifacts that you can claim binary provenance on. You can record and attest. And then the next thing is like a very hot topic just now is software supply chain. So it's managing what libraries, what third-party systems are coming into your applications as well. So a typical way to manage this is through some kind of artifact registry where you know the libraries you're using, and you can scan them and check them against known vulnerabilities and so on. So going beyond the build, like securing what is the package you're building, the next thing is there's other risks that you need to kind of mitigate for in security and regulated industries. The top one is actually insider threat. It's people, someone inside your organization with access to your systems, decides to put some code into production. And like the very basic way to mitigate against that risk is just to enforce code review. That's great. Code review kind of lessens the chance. You would need collaboration and so on. You can add more people to the list in order to reduce that risk. But from an audit perspective also, you have to record. It's like it's not enough to do the code review. You also have to record somewhere that code review has been performed all along. Because when the auditor comes, they're going to say, okay, give me a list of everything that's in production and show me that everything there has had code reviews. It's like, that's a very basic report that people need. And then also in the journey towards production, you tend to qualify your software. A lot of the qualification process can be done in your DevOps as well, like supply chain, checking your vulnerabilities, doing static analysis, doing change logs, and so on. Yes, there's a question.
Yes, I have a question on the last page. Would you care to elaborate a little bit on when you're building code reviews, like pull requests, you usually get some inertia into the work. Stuff gets delayed, code requests lying around. How do you address these to mitigate the effects?
Yeah, I think that's a great question just for everyone else. It's basically around code review introduces delays. And delays have going back to the culture thing, delays are the one thing that you really would rather avoid. It's the one thing that developers most object to when it comes to building in a secure software development lifecycle. So, I've got some opinions on this too. But so, like, I think that like there's no way to get around it. If you want to make sure that you mitigate insider threat, you need eyes on all the code goes out. And if you're in a high-risk environment, you probably need eyes on all the code that goes out before it goes to production. So it can't be asynchronous. You can maybe get away with it in some cases, but it's messier. What we do in my company is we do pair programming and mob programming. So there's no actual delay. People write the code in a group, it's pushed, and someone else merges it immediately. So it's not like the code review happens in real time. We do it for reasons other than security, to be honest. We do it because we think it's the best way to make software. We think it gives you the highest quality, the best solutions, knowledge transfer. Lots of good reasons to do these things. So in general, we're big fans of ensemble programming, mob programming, pair programming. But yeah, I think like the idea of slinging pull requests at each other is, people don't like it. It adds delays, and in general, it also adds interruptions to those that are expected to break from what they're doing to accept things. So ideally, it's better to work in groups, I'd say. Does that answer your question? Good. So back to our Knight Capital story. They obviously found the problem. One of the servers did not get the fix applied to it. So 7 of 8 servers got basically, I think it was a rollback. But because they were deploying manually, they were doing it without working on their own, without any logs. So this PowerPeg code had not been removed from the 8th server. So it continued going much further than expected. And this is, again, another like classic example. I mean, if you look at the real risk here is that going back to binary provenance, knowing your software, the other part of it is knowing what's running. You have to absolutely know what's in your environments and have a good record of that. This is another great example. I was speaking to a distinguished engineer at one of the big banks in America a few months ago, and he was talking about an example of like it's not enough to know what's running now. You need to know, like, he wants to be able to go through all the Git repos, look for a version of, say, log4j, and all the commits, find out all the commits that have a particular version of log4j, and then be able to query a system to know if that binary was ever running. That's the kind of level you probably need in order to, if you want to go back and do network forensics and so on, of potential breaches in the past. So again, this is kind of another security control, is that you need to be able to control what's going into your production environment with some kind of circuit breaker. It could be just a simple if statement in your build pipeline. It could be more like some kind of deployment controller inside a cluster or so on. But the whole idea is you need to be able to know that what you're going to run is trustworthy, and then keep a record of everything that has run. And so basically the rough idea is that if you can mitigate and record a lot of the risks and the controls have been performed in your process, then for the developers, it can feel more or less like they're working in any other development environment. Like, it shouldn't feel onerous to work in a secure way. Yes, and kind of this story is also just around incident response and having good tools for everybody to be able to understand. Like, when it comes to incident response, that is a really important aspect of like security. Like, bad things will happen. Like, how quickly does it take for you to figure out what's going on, get situational awareness, and fix the problem is a really important part of the solution. So a lot of the concepts I talked about here are, we've worked with a lot of companies in the regulated space, so we've created a software process, like a secure software development lifecycle, if you like, that's free, open source. It works for the most part. So if you're in a world where you think, okay, we're going to go for, or we're going to get a banking license, or we're going to get a payments license, or we're going to get ISO certified, how do we make a software development process that the auditors will be happy and the developers will be happy? This is kind of the distillation of that. So you can clone this, put your own company logo in, delete the bits you don't like, add some bits that are particular to you, and you kind of get quite a good far way along that first bit. If we go back to the needs, you need a process, you need to follow the process. DevOps is great for that, and then you need a record of the process. So you can take a look at this and dig deeper into some of the other concepts that we haven't had time to touch on. Great, with that, back to Stacc.
All right. Yeah, so we had a chat with Mike and the guys, and we got basically this talk just over a slightly longer period of time, just started learning about this. The question, my question then, as one of the people who really wanted to do this, is like, how do we proceed from here? Because as I mentioned earlier, it's a company that is highly diverse, and you have to kind of spread the love in the right way in order to basically be able to do this. So we tried to come up with a plan to kind of go from getting buy-in through creating a proof of concept all the way to passing an audit. So the first thing we started with, which is something developers often kind of ignore, is that you actually have to talk to people and basically listen, right? Start by listening and talking to the different teams. What are the main concerns of the different teams? And just basically gathering information and basically let everyone voice their opinion. And based on this, we try to kind of come up with a general set of guidelines that are really high level, that would kind of satisfy everyone. So we ended up with a super high level of detail process for specifically change management in this case, and that everyone was happy about, but this was super high level. And then we basically, based on the DevOps control framework that Mike just mentioned, we created a kind of, I wouldn't say best practice, but a way of implementing this process using DevOps. And in order to prove that this actually worked, we created a proof of concept for 2 of our main platforms, GitHub and Bitbucket, to basically show that we can have the process that Mike just mentioned in both of these platforms without actually the developers necessarily noticing the difference. We were already doing things like code review to pull requests because, again, we were operating in a regulated environment and a lot of this stuff was required. We just didn't have the proof for it. Yeah, so basically created a couple of these proofs of concept and made sure that actually met everyone's expectations and requirements. And then we had a meeting where we decided, yes, let's go implement this. And in order to do that efficiently, we basically created a small task force of like internal champions, experts, who basically dug into the details a bit more than everyone and helped the different teams implement this. And we also created some reusable tooling because a lot of this stuff is pretty boilerplate to basically have to record like the SHAs and the established binary provenance of the different artifacts we were building. You had to basically make sure that pull requests were recorded in the system, in this case, Coastly. And that you had documentation that made it easier and easier for the different teams to implement this. So basically, this task force was responsible for spreading the word. And then we had to do this gradually because, again, as with software, it's never right the first time. So we found a team that was more or less willing to be guinea pigs. So we used them to kind of test this process, tweak it, and improve it. And then we started to kind of scale this. Yeah. And we're still continuously scaling this. And then late November, it was actually time for audit, which was a bit terrifying, to be honest. So an ISO audit, what does the auditor actually want to know? And it's pretty much like Mike mentioned, that you have a defined process and prove that you're following it. That's basically it. So how did we actually assure them that we were compliant? Well, when it came to change management, we could actually just point to our Coastly dashboards that said, okay, this change has been through this process, it has been code reviewed by this person, it has been approved for deployment by this person at this time, and it's currently the thing that's running in production. So this quote from the auditor I really liked because he said, like, okay, so this takes away a lot of the work that I need to do every time I go into an organization, and also a lot of work from the organization to kind of gather all the evidence to prove that you're actually following the process. We don't need to do that because we already gathered that from the get-go. So that was actually, the audit was less horrible than I expected. Yeah, and as I said, we're not done yet, right? We keep rolling this out across the organization. Some teams were more DevOps than others and had an easier time of implementing this. Some teams are still lagging behind. Some teams are still kind of using manual checklists and so, but we're kind of continuously rolling this out, and I'm pretty confident that pretty soon we'll have a relatively standard way of doing this across the organization. And we're also continuously improving this, right? Because as you get new security concerns, like there's a higher focus on tool chain or like external tools affecting the our tooling, which means that we need to improve the way we scan our software, and that also needs to be recorded that we're doing that. So we're continuously improving this. So some key takeaways from this process, like as Mike mentioned with the IKT-forskriften, it's pretty basic high-level rules, so it's not that prescriptive. you basically have to find your own way of implementing stuff. That was a bit surprising for me, who didn't really have a background for this, but we basically had to create our own process, and we also had the freedom to do that. Again, the real world is messy. We have a relatively young company, but it's spread out and not a lot of hierarchy, and that has some challenges. Other companies, large bureaucracies, would have different ways of implementing this. Yeah, that's definitely a takeaway. And you can't do everything at once. You basically have to do this bit by bit and start small and continuously increase. But it doesn't really have to be that hard. I actually was pretty surprised after going through this process that it actually came down to a couple of lines of code in our pipelines on the most important steps in our build process. That's mainly what actually had to change in the end. And employees actually end up being more happy because, again, who wants to be the person who lost, like, was it $460 million? Not me. So if you can actually prove that you're following a process, you got your back covered. Yeah. So that's it for me. So are there any questions?
I'm looking back at the 4 concerns that you have on speed, for example. What are those do you think you had to compromise most or at all? If you would just be totally free to develop the way you wanted to, and what of those 4 things did you have to make the most significant deviation?
I would say none of them, because again, we were already doing a lot of this stuff, like code reviews, since we needed to do that anyway. So it's not like we didn't have compliant pipelines or compliance built in before. We just didn't prove it. So I would say we didn't really. I think we met all of the requirements in the end.
Maybe I think that, like, thinking back, it would be more like going down that journey. If you'd taken a more traditional approach, it might have involved like a ticketing system or some kind of change process, which maybe would have it's more like avoiding a cost than gaining a benefit in a sense. So, like I said about developers, we tend to be quite good at like finding ways around, and I think this is just another example of like, okay, ISO is it's a reality, we have to live with it. Well, how can we swim around this to make it like it doesn't exist in a way?
And it's actually better, I would say, than a manual process, because then you have manual steps and humans who are prone to failure. So I think we honestly got out in the other end and were actually better for it.
Yeah, and I think like the other pain that was kind of really missed is the audit processes can be quite extreme. I know companies that have been through like month-long audits on IT because they have to go through every single ticket and every single pull request, and the auditors, because if the evidence is there, they'll keep pulling until they get the answers they want. So it can be not very comfortable in that situation if you don't have good records.
Yeah, and other parts of the implementation, we actually have that problem, right? Because we don't have an automated process for all of the requirements. So a lot of that actually still needs some manual processes, and so we're talking about that.
Okay.
So how long was the timeline from when you decided we want to be ISO certified till you actually were? Can you tell me about the process?
I think it was decided that we were going to be ISO certified in around this time last year, and then we had the certification in December, I think. So it's a fairly short amount of time in this context.
Yeah, I think that's also quite an unusual journey, because like often these processes can be quite, a lot of the time taken in a certification process is internal meetings about what our process is going to be. And I think that you can squeeze that a bit if you can just get some basic like alignment on how it should be quickly, and then the implementation is actually quite fast. It's the alignment that can take time.
Yeah, and it helps to be small and agile, right? Because again, if this was a huge bureaucracy, I think it would have taken a lot longer, just because all of the interactions you need to have.
Great. But then thanks everyone for your attention.